Right, so back in 1965, a bloke named Richard Feynman stood in front of a room full of the smartest physicists on Earth and basically admitted defeat. He said, and I quote, "Nobody understands quantum mechanics. Not him, not Einstein, not anyone." And he wasn't being humble. He meant it. Because hidden inside the most accurate theory in human history is something so disturbing, so fundamentally broken about reality itself that Feynman spent his entire life circling it without ever cracking it open. Tonight, I'm going to show you exactly what he saw. And once you see it, you cannot unsee it. Here's the thing that messes people up. Quantum mechanics works. It's the reason your phone exists, your laptop, GPS, MRI scanners. Every single piece of modern tech runs on predictions made by a theory that its own inventor said was incomprehensible. How do you trust a map when the person who drew it tells you the territory doesn't make sense? That's the paradox Feynman lived inside his whole career. And the weird bit, the truly cooked bit, is that the more accurate quantum mechanics gets, the less reality seems to behave like anything we'd call real. Let me take you back to the experiment that started all this. You've probably heard of it. The double-slit experiment. Sounds boring, I know. Two slits, a wall, some light. But Feynman called it the single most profound experiment ever performed. He said, and this is straight out of his lectures, that this one experiment contains the only mystery of quantum mechanics. Everything weird about the quantum world, every paradox, every sleepless night a physicist's ever had, all of it lives inside this one setup. So stick with me because this is where things go sideways. You fire a single electron, one tiny particle, at a barrier with two slits cut into it. Behind that barrier, there's a screen. Now, common sense says the electron has to go through one slit or the other, yeah? It's a particle. It's got to pick a lane. But when you run the experiment, something absolutely bonkers happens. The electron doesn't pick. It goes through both slits at the same time. And not in some metaphorical way. It literally interferes with itself like a wave crashing against another wave. One particle, two paths, simultaneously. Now here's where Feynman leans in closer because you might be thinking, all right, maybe the electron is a wave. Maybe it spreads out, fine. So physicists set up a detector, a tiny little camera basically watching the slits. They want to catch the electron in the act of being in two places. And the exact moment you switch that detector on, the wave pattern vanishes. The electron suddenly behaves like a normal particle. One slit, one path, like it knew you were looking. Stop. Think about that for a second. The electron changed its behavior based on whether it was being observed, not touched, not interfered with physically. Just observed. That's the disturbing part Feynman kept coming back to. Because it means reality, the actual fabric of what's happening, depends on whether someone's checking. And nobody, not Feynman, not any physicist since, can tell you why. Now, Feynman did something clever. He didn't try to explain why it happens. He gave up on that. Instead, he built a mathematical tool so powerful it let him calculate what happens without pretending to know what's going on underneath. He called it the path integral, sum over histories. And the idea is absolutely wild. He said, right, if we can't tell which path the electron takes, then maybe it takes every possible path, every single one, through both slits, around the back, through the moon, through a coffee cup in another galaxy, all of them, simultaneously, and they all add up to give you the final answer. Sounds like a joke, right? But it works. It works so well, we use it to design microchips. It's the most accurate predictive tool in science. And yet, if you ask what it means, what it's actually describing about reality, Feynman would shrug. He'd literally shrug. Because the maths gives the right answer, but the answer it gives is that nothing has a definite history until you measure it. All right, hold that thought because this is where most videos stop. But this is the bit that haunted Feynman. This is the part nobody talks about. See, most people walk away from quantum mechanics thinking, okay, small stuff is weird, big stuff is normal. The tables and chairs and footies and coffee mugs in your kitchen, they behave themselves. Only atoms go sideways. That's the comfortable lie we tell ourselves. But here's the disturbing truth Feynman saw clearly and couldn't shake. You are made of atoms. Every cell, every neuron, every thought in your head is, at the bottom of it, running on quantum rules. If atoms don't have definite states until observed, then neither do you. And neither does anything you've ever touched. Let me give you a real-world example. You're driving home tonight. Headlights on. The light hitting your windscreen. Every photon, every single particle of light. according to Feynman's own maths, is taking every possible path to your eyes, bouncing off Mars, reflecting off your neighbor's dog, going the long way round the universe, all of it, simultaneously. The only reason the world looks stable and solid is because all those weird paths cancel out and leave you with what looks like normal reality. But underneath, it's chaos, pure, undefined, indeterminate chaos. Here's the twist, though, and this is the part that changes everything. Feynman wasn't just freaked out by the weirdness, he was freaked out by something deeper. He realized that quantum mechanics isn't incomplete, it's not missing a piece, it's not waiting for some smarter bloke to come along and tidy it up. The theory is exactly as strange as reality actually is. The problem isn't the maths, the problem is us. Our brains evolved to hunt and gather on the savannah. They're not built to handle a universe where things don't exist until looked at. Our intuition is broken, not the theory. And that right there is the disturbing truth. We are monkeys with phones trying to understand the code of the universe. And the code flat out refuses to make sense in monkey language. Einstein hated this. Absolutely hated it. He spent the last 30 years of his life trying to find a way out. He came up with thought experiments, paradoxes, traps. Every single one was eventually tested in a lab, and every single time quantum mechanics won. The universe keeps telling us, in experiment after experiment, that reality is not definite, it's not local, it's not what you think it is. And Feynman knew it. He just had the honesty to admit nobody could explain why. The deepest cut, the part that I reckon truly kept Feynman up at night, is what this means for the question of what reality even is. If a particle doesn't have a position until measured, does it have a position at all? If an electron takes every path, which path is the real one? And if you push that logic far enough, you end up at a conclusion so unsettling most physicists won't say it out loud. Maybe the universe doesn't have a single definite history. Maybe reality is a story that only gets written when someone reads it. And we are both the readers and the characters at the same time. Feynman got a Nobel Prize for the path integral. He gave us the tool, but he never gave us the answer. In his last years, he was asked what he'd say if he could leave one message for the next generation of physicists. He said something along the lines of, "Shut up and calculate. Don't ask what it means. Just use the maths." Because the moment you ask what's really going on, you fall into a pit nobody's climbed out of in 100 years, and I don't reckon anyone will anytime soon. So here's where that leaves us. The most successful theory in human history describes a universe where things don't exist until measured, where particles take every possible path at once, and where the man who understood the maths better than anyone admitted nobody, and he meant nobody, understands what it all means. That's Feynman's disturbing truth, not that the universe is weird, but that it might genuinely be beyond human understanding. And the wildest part? We built phones out of it anyway. If this rewired your brain even a little, smash that like button. Subscribe if you want more physics that mucks with your head like this. And tell me in the comments, do you reckon we'll ever actually understand quantum mechanics, or was Feynman right? I'll see you in the next one.